Ever get that feeling watching a sci-fi movie? You know when some mysterious signal pops up out in space and hints at something totally out there?
Yeah, like we are not alone.
Yeah, exactly. Well, guess what? It's happening right now, but for real. Astronomers are baffled by a radio signal, totally unlike anything they've ever seen before.
It really shakes things up, like all our ideas about what's out there in the cosmos. We have these frameworks and the signal, it just doesn't fit.
Right. And where is this cosmic riddle coming from? The constellation Sagittarius? Way out there, about 13,000 light years away.
Oh.
And it was the Australian Square Kilometre Array Pathfinder, ASCAP, that picked up on this super strong radio emission.
Yeah, ASCAP. It's an amazing instrument. I mean, it can scan huge parts of the sky, and it's so sensitive that we are finding all sorts of new things we would have missed before. Things like this.
Okay, but here's where it gets really wild. This isn't just a one-off blip. This signal repeats every 6.5 hours. It's like clockwork, a cosmic clock, super precise across all that distance.
It makes you think, right? You know how rare that is, that kind of regularity in space. Most of what we see is chaotic, always changing. This is like boom, 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 steady as a drumbeat, a clue.
Definitely. And the lead researcher, Manisha Caleb, she summed it up perfectly. She said, "Never before have we seen this type of periodic signal, so unusual that it cannot be explained with our previous ideas about celestial bodies." I mean, that says it all right. This is something totally new. It's like discovering a new color.
Totally agree. It really shows that we don't know everything about what's out there. There's probably all sorts of things out there we haven't even imagined yet. Whole categories of objects and phenomena just waiting to be found.
Now, they have given this weird thing a name. ASCAP J1839-0756. Not very catchy, is it? For something so bizarre.
I know, right? Like they couldn't come up with something a little more, exciting.
No, exactly. But I guess for scientists, it's important to be precise. Those letters and numbers, they're like a fingerprint. So there's no confusion when they're talking about it.
Right. Makes sense. Universal language for a universal mystery.
Okay, so, when we think about radio signals coming from space, what usually comes to mind, I'm thinking pulsars.
Yeah.
Those super fast spinning neutron stars, they send out beams of radiation, or maybe a giant star exploding way out there.
Exactly. Big energy events. That's what usually makes these radio waves we pick up, like pulsars. They spin so fast with these crazy strong magnetic fields. It's like they are cosmic lighthouses.
No.
And supernovae, massive explosions. They blast out energy, including radio waves.
Right. But this signal, ASCAP J1839-0756, it doesn't fit. It's way too slow to be a pulsar. They pulse hundreds of times per second sometimes, and it's too close to be a star exploding. Joshua Lee, one of the researchers, said, "We have something completely new before us. It behaves like no other astronomical object known to date."
He's not kidding. I mean, that quote really hits home how much we are in uncharted territory here. It's exciting. We need to think outside the box, way outside.
Totally. And it gets even weirder. Between those main 6.5-hour pulses, they are picking up a second signal a lot weaker. They call it an interpulse.
It's like, okay, so imagine a cosmic teenager who hits the snooze button a couple of times before actually getting out of bed.
Huh. I love that. Okay, so then on top of that, over about 6 months, the signal starts to fade, weaker and weaker, until, poof,
yeah,
nothing. The radio waves just disappear completely.
Vanish.
Gone. And then later, they come back.
So there's some kind of cycle at work here, right? It's not constant. Something is turning it on and off or up and down, and we have no idea what.
I know. So at this point, I think it's totally normal to start thinking about some pretty wild explanations, like dark matter. Or maybe even,
aliens. Yeah, it's natural for your mind to go there. But for scientists, they've got to start with what they know. The astrophysics, even if this thing doesn't fit neatly in any of the usual boxes.
Absolutely. So what are some of their best guesses? Well, one idea is that it could be an incredibly slow neutron star. I mean, we know neutron stars are already these incredibly dense objects, like a star that's collapsed in on itself. But this one would be the slowest one ever found. Like most neutron stars, they spin so fast, hundreds of times a second sometimes. This thing pulses every 6.5 hours, a real slowpoke.
If this is a neutron star, we would have to really rethink how we understand them, how they lose their spin. Maybe it formed in some really weird way or has something going on inside that we don't know about.
Okay, so then another possibility, what about a magnetar? It's like a super-powered neutron star. Like imagine a magnetic field trillions of times stronger than Earth's.
Oh, yeah. Magnetars are something else.
Some of them do send out bursts of radio waves, but again, none that we know of rotate as slowly as this mystery object. Magnetars are known for their crazy magnetic fields. and sometimes they do some pretty wild things.
Huh.
But their rotation is usually much, much faster than what we're seeing here.
Right. If it was a magnetar, we'd expect to see other signs, other types of emissions. And that long, slow pulse. Not really what they do.
Okay, so what if it's a binary star system? Two stars orbiting each other, and one of them is causing these radio waves. But again, that doesn't really explain everything. Joshua Lee said, and this is a great quote, "It's as if we have a puzzle in front of us where the pieces simply don't want to fit."
Yeah, and the binary idea has some problems too, like why the pulses are so long and so regular. And that secondary pulse we talked about. Hard to explain that with just two stars orbiting each other. Sure, gravity between two stars can cause some interesting things. But to get this kind of signal, those stars would have to be in some very specific and very weird arrangement.
Right. Okay, so let's add another piece to this puzzle. This signal, it's incredibly strongly polarized. Imagine waves on the ocean, right? They're usually going all over the place. But what if all those waves suddenly lined up and moved in the same direction? That's kind of what's happening with these radio waves. They aren't just randomly going out. They are all lined up, all moving the same way. This tells us there's some incredibly powerful magnetic field out there acting like, a traffic cop.
Yeah. And that polarization, it's like a giant arrow pointing us towards some extreme physics. Those magnetic fields must be off the chart strong to do that.
And there's more. The astronomers have noticed that the wavelength of the signal actually changes over time. So when they look at lower radio frequencies, the signal is stretched out, broader. Compared to when they look at higher frequencies, they see this with pulsars.
Interesting. So this is telling us something about what those radio waves are traveling through, right? Maybe some kind of gas or dust. And it can give us hints about what's creating the signal in the first place. Like it's picking up echoes from its surroundings.
Okay, so let's put it all together. The super slow pulses, super regular. The mystery interpulse, the fading in and out, the polarization super strong, the wavelengths changing. This is like nothing we've ever seen. It's like Manisha Caleb said, all these characteristics together result in a very unusual object. It combines characteristics of various known phenomena, but does not fit into any of the established categories. So it's kind of like a hybrid. It has bits and pieces that look familiar, but it doesn't match anything we know.
Right. It's like nature took bits and pieces from different objects and put them together in a new way, a new recipe, and we were just trying to figure out what the heck it is.
But what have they done? They've been pointing all sorts of telescopes at this thing, all across the spectrum. Radio waves, infrared light, X-rays. They want to see if this object gives off any other kinds of signal.
Right. It's like detective work. You got to use every tool you've got. Different wavelengths, they show us different things happening. Like X-rays show us really hot stuff. Infrared, that's more about cooler things. It gives you a much more complete picture.
I like that. A cosmic detective story. Yeah. So what did they find? Nothing. Not a peep in any other part of the spectrum. Just that one weird radio signal. Joshua Lee said, and I love this, it's like we have a ghost in front of us. We hear it, but we can't see it.
That's spooky.
Definitely. And the fact it's not emitting anything else, that really narrows things down. A lot of things in space, they give off lots of different types of energy. This one's quiet, except for this radio signal. Must be something very specific, very unusual causing it.
Okay. So then, just when they thought this cosmic ghost was gone for good, months later, guess what?
It came back.
It came back. Weaker this time, but still pulsing with the same 6.5-hour rhythm. Right on time.
Wow. So that tells us that whatever is making that pulse, it's still there, even though it's not always sending out the same amount of energy. Right. Now, this on-again, off-again thing reminded the astronomers of another group of strange objects called, and this is a mouthful, long-period radio transients. These are objects that send out bursts of radio waves, but at random times, and then they go quiet. The thing is, none of these transients have a period as precisely timed as our friend ASCAP J1839-0756. None of them.
So we are seeing some similarities, but also big differences. Like the mechanism that's making the pulses, it might be similar in some ways. But whatever is making this one so precise, so steady, that's something unique.
Totally. And Manisha Caleb said, and this is really interesting, it's as if we have discovered a completely new class of astronomical objects, one that combines the properties of several known phenomena, but also has its own unique and previously unknown characteristics. It's like we've found a new species, a new cosmic creature.
Yeah. If she's right, this could really change how we think about all kinds of things. How stars are born, how they live, how they die. Huge implications.
And get this. She thinks there could be hundreds of these things in our galaxy alone. Hundreds. We just haven't seen them before.
Wow. Hundreds. That means that whatever conditions are needed to create these things, it's not as rare as we thought. We just haven't been looking the right way.
Exactly. So why haven't we seen them before? Well, the way we've been searching the skies, it wasn't designed to pick up on signals this slow. It's the new telescopes, the really powerful ones like ASCAP, that are making these discoveries possible.
It's really exciting. I mean, with these new telescopes, we're just starting to scratch the surface. Who knows what else is out there?
I know. And with the square kilometer array coming online soon, that's even more powerful. I can't wait to see what they find.
I know. It's like opening a present. We have no idea what's inside.
So I think the big takeaway here is that the universe is full of surprises. Just when we think we are starting to understand things, something like this pops up. That's what makes astronomy so amazing.
Absolutely. Every new discovery, it's like a reminder of how much we don't know. It keeps us humble and keeps us asking questions.
So here's something to think about. This weird signal, could it mean that our understanding of how stars work is totally wrong? Maybe there are things going on that we haven't even considered. What other assumptions do we need to question? It really makes you think.
It does. It just shows you there's still so much out there to discover. And the more we find, the more we realize how much more there is to learn.
Exactly. And that's what makes it all so exciting. So keep looking up at the stars, folks. You never know what you might find.
Absolutely. The universe is full of wonders.